All right, problem number 70. The intensity at the central maximum of a double-slit interference pattern is 4 times I1. The intensity of the first minimum is 0. At what fraction of the distance from the central maximum to the first minimum is the intensity just 1 times I1? All right, so in our two-slit pattern, we have some fringes, and we could say this is the central max. And here we have the first minimum. And we're told that this guy has an intensity which is equal to 4 times I1, where I1 is, the intensity through one slit. And the intensity here at the first minimum is 0. So somewhere between this central location where the intensity is 4I1 and this location here where the intensity is 0, somewhere in between from here to here, the intensity has to be just 1I1, just I1. So 4I1, and then we're going to coast down, and at some point it's 0. So somewhere in between, the intensity has to be just I1. So our goal here is to find the location of the first minimum and find the location where the intensity is I1, and then it specifically asks for the fraction of the distance. So if this is the full distance, are we halfway? Are we 3/4 of the way? What is the fraction there? So we need our intensity equation for a two-slit pattern for this, and that is the intensity of a two-slit pattern is given by 4 times I1 times the cosine squared of pi times d, where d is the spacing between the slits, divided by lambda, where lambda is the wavelength of light, times L, where L is the distance to the screen, times y, where y is our coordinate. Here we will choose plus y, points in this direction. Y is our coordinate from the 0 position outward. Okay, so this produces an intensity that increases and decreases. It's cosine. You can never have a negative intensity, so this goes from 0 to 4i, or 4i1, and is periodic as we have this bright, dark spot. Okay, so we want to find out what the position is when this is equal to just I1. So I1 is equal to 4 times I1 times the cosine squared of pi times d over lambda L times y. Okay, and so this is the position of the first minimum, which I will call y1. And so our goal here is to solve this expression for y1. So first of all, the I1s cancel. Could bring the 4 to the other side, so we're going to get 1/4 is equal to the cosine squared of pi times d over lambda L times y1. Now we'll take the square root of both sides, so we're going to get a 1/2 on the left-hand side. It's equal to the cosine of pi d over lambda L times y1. Now we can take the inverse cosine of both sides, so we're going to get the cosine inverse of 1/2 is equal to pi times d over lambda L times y1. And now we just need to solve this for y1. We're going to get that y1 is equal to lambda L over pi times d times the cosine inverse of 1/2. All right, let's go ahead and get rid of this cosine inverse of 1/2. So we want the cosine, which means the x value is going to be 1. The hypotenuse is going to be 2. That makes this guy root 3. So this is 60 degrees, which is pi over 3. So I'm going to go ahead and replace this with the pi over 3. So this is equal to lambda L over d times pi over 3. Pi's are going to go ahead and cancel. And so this is equal to lambda L over 3d. All right, so we found the position where the intensity is equal to I1, and it's lambda times L over 3d. Now this is meters divided by meters, so this is going to give us units of meters. And so now we also need to compare that to the position of the first minimum. And the position of the first minimum, I will call y0, is going to be equal to all right, the position to the first minimum. Well, let's just go ahead and start with the angle of the first minimum. So we'll get back to this in a moment. We have that the angle of the first minimum is going to be m plus a half times lambda over d. Okay, this is one of our equations for the two-slit pattern. And if we take m to be 0, this is equal to lambda over 2d. And y is equal to L times the tangent of theta. And for small angles, this is approximately equal to just L times theta, which is going to give us lambda times L over 2d. Okay, so this is y0, theta 0. And the last thing is to calculate that ratio then of y1 divided by y0. And for y1, we had lambda times L divided by 3d. And for y0, we had lambda times L divided by 2d. So everything here cancels, and we're left with 2/3. 2/3. Okay, so that means that the coordinate of this I1 is 2/3 of the way to y0. So that's going to put it, somewhere along here. This is where the intensity is equal to I1. And that is how we do problem 70.